Now, we previously learned how to solve one-step equations, and now we're going to solve equations that take more than one step. So we're going to be using at least two of our different properties of equality in order to solve these. But even though these are going to be more complex equations, the idea is still the same. We're going to find our variable, which in this first problem, the variable is x, and we're going to do whatever math stuff we need to do to get the variable by itself. In this equation, there are two things that need to go for the x to be by itself. One is this 11, and one is this minus 4. Now, technically, you can get rid of these in either order. We can get rid of the 11 first and then the minus 4, or we can get rid of the minus 4 and then the 11. It is almost always better when you are solving an equation to go in reverse order of operations. In other words, order of operations would say do multiplication first and then subtraction. In this case, it's actually better to do subtraction. In other words, get rid of the subtraction and then get rid of the multiplication. And let me show you why. So don't write this down. If you're taking notes following along, do not write this down. But if I were to divide by 11 first using the division property of equality, I would have to divide both sides of the equation by 11, right? Whatever I do on one side, I have to do on the other. So on the left side, I will have 11 to x divided by 11, which gives me x. But then I will also have to do 4 divided by 11, which was 4 elevenths. And then 29 divided by 11 is 29 elevenths. And I can still solve this. There's nothing wrong with this problem, except now I've got a problem that did not have fractions that now has fractions in it. We can solve an equation that has fractions. We can do it, but it's certainly much more difficult than if we solved it without having fractions. So if instead I did order of operations in reverse and I took care of that minus 4 first, let's use the addition property of equality and add 4 to both sides. Now I avoid the fractions. I have 11x on the left side, and 29 plus 4 is 33, and now I've avoided the fractions. I'm going to go ahead and write my property that I used. I used the addition property of equality. I want to justify my answer, the addition property of equality. I added 4 to both sides. And now I'm one step away from the answer. I want it to be x equals, and I have 11x equals, so I'm going to divide both sides by 11. 11x divided by 11 and 33 divided by 11. 11x divided by 11 is just x, and 33 divided by 11 is 3. And this is using the division property of equality, which I'm going to abbreviate, division property of equality. My answer is x equals 3. If I had continued solving this over on the left side using fractions, I would have gotten the correct answer. I would have used the addition property of equality to add 4 elevenths to both sides. And 29 elevenths plus 4 elevenths is 33 elevenths. So I would have gotten the same answer, 33 elevenths, but I would have had to deal with fractions. And if I can avoid dealing with fractions, I want to. Sometimes we're forced to deal with fractions, like in the next problem, we just have a fraction in the original problem, so we're going to have to deal with the fraction. But if I can avoid fractions, why wouldn't I? So let's go ahead and take a look at this second and final problem. It is a plus 7 over 8, and the whole thing equals 5. And so the first thing we're going to do is find our variable and see what do we want to get rid of. Well, we need to get rid of the plus 7, and we need to get rid of the divided by 8. Now, you may think back to what I said just a few minutes ago on that last problem and say, well, you said do reverse order of operations, so surely we should get rid of the plus 7 first and then get rid of the 8. But remember, I said almost all of the time, reverse order of operations is easier. It turns out in this case, it's actually easier to get rid of the 8 first. And the reason it's easier to get rid of the 8 first is because I can't just subtract 7 right now, because that is not actually a 7. That 7 right there is not a 7. This is, and again, don't write this down, this is the same thing as 8a over 8 plus 7 over 8. And I just crammed those together as one fraction to get a plus 7 over 8. So I would not be subtracting 7 on both sides. I would actually be subtracting 7/8. So because the problem is written as a fraction, I'm already dealing with fractions right from the get-go. So my strategy here is going to be, is there something I can do right at the beginning so that I am not dealing with a fraction? And the answer actually is yes, there is something I can do to eliminate the fraction. See how I've got this line right here with the 8 on the bottom? Well, a fraction line is just another way of writing division. This is a plus 7 divided by 8. And so if I multiply this by 8, what will happen is the 8's will cancel, and I'll be left with just a plus 7. That's the division property of equality. I mean, not the division property, derp. The multiplication property of equality, because I'm multiplying by 8. Multiplication property of equality. If I multiply that side by 8, and I also multiply this other side by 8, I have a plus 7 equals, and then 5 times 8 is 40. Now I have no fractions, and I'm one step away from the answer, which is just to subtract 7 on both sides. This is the subtraction property of equality. 7 minus 7 is 0, leaving me with just a. And 40 minus 7 is 33, the subtraction property of equality. Now, could we have solved it by leaving it as a fraction 7/8? Technically, yes, but our next step here would have been to subtract 7/8 on both sides, and we would have had a over 8 equals, and then 5 minus 7/8 is 4 and 1/8, or 33/8. And now we would multiply both sides by 8 using the multiplication property of equality. And our 8's would cancel, and we'd end up with a equals 33. So we get the same answer no matter which step we start with, but I think it's pretty clear one of those steps is certainly easier to do first. So as you're solving these, it's worth taking just a minute to look at the problem and think to yourself, okay, I know I can do anything first and I will get the right answer, but is there something where if I do this thing first, it's going to make life a little bit easier for me? And the answer is usually yes. One of the steps is usually going to be easier to do than the other.